Dear students, I welcome you to this lecture on game theory practical problems. In my previous video, I explained about the game theory and its principles and mixed pure strategy, mixed strategy and graphical method, how to solve the various problems by using game theory that I have already explained in the previous video. If you missed that video, I request you to watch that video and then to watch this second video on game theory. And here we will be explaining only about the practical problems related to game theory. So let us see this problem. And there are two players are playing a game, and this is with matching coin, and player B toss coin. Player A wins 20 rupees when there are two heads, and if there is a two tails, and he gains nothing. So the rules of the game is like this. Their player B is tossing the coin. When they toss the coin, that may be a head or maybe tail, and player A need to guess whether he is going to get the head or tail. So if suppose player A say it is head, and after tossing, if it is also head, because it is matching, so he will gain 20 rupees. And if suppose if he say it is a tail, and if it is matching, still he will not lose anything and he will not gain anything, nothing he will gain. But if suppose if he say head, and instead of head if he get a tail, then he need to pay 10 rupees to B. So this way, even if he say tail, and if suppose if there is a head, in that case also he need to pay 10 rupees to player B. So that is the game. So here we need to determine the payoff matrix, what is the best strategy for each player, and value of the game. So this is the problem. So let us see how to solve this practical problem by using our known methods. So any problem if you wanted to solve, the first step will be we need to first have the payoff matrix. So we first develop the payoff matrix. So here the condition is player A wins 20 rupees when there are two heads and gains nothing when there are two tails. So here if you see this matrix I already given. So here is the player B and here is the player A. So player A, he gains 20 rupees if it is a head. So first strategy is head. So he gets the head, and if it is matching, so player A will get 20 rupees. And if suppose if it is matching the tail, that is let us say strategy 2, and he will gain nothing and he will lose nothing, so it is 0 value. And if suppose if it is not matching, he say it is head but there is a tail, and he said it is tail and there is a head. In these two cases, player A will lose 10 rupees. That is why it is called as minus 10. So this is the payoff matrix for the given problem. So now one need to solve. How to solve this, that we will see. Sorry. So now let us solve this problem. So now first of all, because we need to check with the minimax criteria, but here minimax criteria, here minus 10 and here also minus 10, but here 20 and 0, so minimax criteria is not satisfying. So that is why I just directly applying the odd-man matrix, and I can't even apply the dominance, even I can apply the dominance principle, but still it will not cancel, because here minus 0 and here minus 10 20, so nowhere it will get cancelled. So that is why if it is a 2 by 2 matrix, so I am directly applying odd-man method. So now if I apply odd-man method, so here I will be calculating the oddments. Oddment is the difference between these two. So it is 10 minus 0, it is 10, and here 20 minus of minus 10, it becomes a 30. So then the probability of player A gaining strategy 1 will be Okay, let us calculate column wise also the oddment. Here the oddment will be difference between this that is 10 and here 30. So the probability of player A for with the strategy 1 will be P1 will be is equal to 10 by 10 plus 30. That means 1 by 4. The same manner for probability P2, that is 30 by 30 plus 10, that is equal to 3 by 4. Similar manner, if I calculate the probability for the columns, the Q1 is equal to 10 by 10 plus 30, that is 1 by 4, and Q2 will be 30 by 30 plus 10, that is 40, so that becomes a 3 by 4. So now value of the game will be 20 into 1 by 4 minus 10 into 3 by 4. So the value of the game will be minus 10 by 4. So this is how we will be solving the problem. So finally we can say strategy of player A is in the probability of A 1 by 4 comma 3 by 4, and the strategy of player B is in the probability of B of 1 by 4 comma 3 by 4. The value of the game is minus 10 by 4. So this is how we will be solving the problem. Let us go to the next problem. And here this second problem, there are two players are playing the game in which each player has 4 coins, 1 2 3 4 5, and each of them select a coin without the knowledge of the other person. If the sum of the value of the coins is an even number, A wins B coins. If the sum is an odd number, B wins A coins. So we need to develop the payoff matrix, and also we need to determine the optimal strategy for player A and B. So before that, I just wanted to show one small video where two people are playing. So you watch this video, I will be explaining. So this problem we will better understand by seeing the video here. So if you properly understand here, first we need to develop a payoff matrix with respect to player A, and let us say here is the player A and here is the player B, and the strategy of player A and player B is, first strategy is 1 rupee, second strategy is 2 rupees, 5 rupees and 10 rupees, and here also player A 1 rupee, 2 rupee, 5 rupees and 10 rupees. Now this payoff matrix we need to build. So whenever the sum become the sum of these two coins becomes a even number, so player A will gain the coins, and if it is odd number, the sum is odd number, player B will take the coins. Now for example, now let us say the first player A selected 1 rupee and the player B also selected 1 rupee. So both of them have selected 1 rupee only, but the sum will become 1 plus 1, that is 2, even number. So at that time the total sum of the rupees will go to player A. That means he will get 2 rupees, but out of 2 rupees 1 rupee of his only, another rupee will be from player B. So that means because of this strategy he got 1 rupee, which is a profit to him. So and again let us he also again selected 1 rupee only, but player B taken 2 rupee. Then the sum will become the 1 plus 2, that is the odd number. So in the odd number, if it is odd number, player B will take the rupees. So at that time, and he has kept 1 rupee here, and that 1 rupee will go to B. So that means 1 rupee is the loss to player A because of this the second matching. And the third matching, he selected 1 coin, 1 rupee coin, and the player B selected a 5 rupee coin. The sum will become 1 plus 1 plus 5, 6 rupees. 6 rupees is the even number. So even number means the total money will go to the player A. But what is the profit? The 1 rupee which he kept is his only, but the remaining 5 rupees he will be getting from player B. So that is why he will get the profit of 5 rupee. Then with the third strategy, he will be fourth strategy, 4 and 1. So he selected 1 rupee and player B given 10 rupees. The sum will become an odd number, but he will be getting only 1 rupee minus. That is why 1 rupee is lost to player A. That is why we write minus 1. So the total payoff matrix we are writing with respect to player A only. because the player A either is gaining or either is losing. That we are actually representing in the payoff matrix. So that is why we are developing a payoff matrix with respect to player A. So then again let us go to the next row. If you go to the next row, he will select the 2 rupees, and let us see the sum of the rupees with respect to 2 rupees. So now he has selected 2 rupees and the player B selected 1 rupee. The sum will become the even number, odd number. So he will be losing 2 rupees. So minus 2. And if both of them select 2 rupees, sum will become 4 rupees, but he will gain 2 rupees. And the player B select 5 rupees and player A select 2 rupees, the sum will become the odd number. So player A will lose 2 rupees, minus 2. And both of them have selected the player A selected 2 rupees, player B selected 10 rupees. The sum will become the even number. So even number means total money will go to player A, then it will become the 10 rupees is the profit for player A. Then third row, if you come, and he is selecting 5 rupees, and this is the strategy 3, and here he is selecting a 1 rupee. So 5 plus 1 6 rupees, so profit is 1 rupee. And here 5 plus 2 7 rupees, which is even number, so he will be losing 5 rupees, minus 5. And 5 plus 5 10 rupees, he will be, it is a even number, so he will be gaining 5 rupees. And 10 plus 5 15 rupees, which is odd number, so the player A is losing the 5 rupees, minus 5. The finally he is selecting 10 rupees, and if he select 10 rupees, 10 plus 1, it becomes a odd number, so he is losing 10 rupees. And if he select 2 rupees, 10 plus 2, it is a even number, so he is gaining 2 rupees. Then if he select 10 rupees versus 5 rupees, it becomes a odd number, so he is losing minus 10 rupees. 10 rupees he is losing. Finally, if both of them select 10 rupees, so he will be gaining 10 rupees. So this is the payoff matrix. Now let us see which strategy will give more profit to player A or player B. That we are going to see from this payoff matrix. So let us solve this problem by using regular method. So let us first what we do, the first initially we will be seeing the applying the mini-max criteria. So if you apply the mini-max criteria to this payoff matrix, so here the minimum value in this row will be minus 1, and a minimum value in the second row will be minus 2, minimum value in the third row will be minus 5, minimum value in the fourth row will be minus 10. And in the same manner, the maximum value in the column, first column will be, the maximum value is 1 rupee, and the second column is 2 rupees, third column 5 rupees, and fourth column 10 rupees. So if you observe here, these are all positive values and these are all negative values. So here the out of this minimum values, the maximum value is minus 1. Out of all maximum values, minimum value is 1. So these two are not same. 1 minus 1 is not same. So by after applying minimax criteria, we can say that it is not a pure strategy problem. So we will go to mixed strategy problem. So when we so once after you consider this is a mixed strategy problem, we need to reduce the number of columns and rows. So only then we can able to solve the mixed strategy problem. So here we will be applying the dominance property. So now if you apply the dominance property, first we will be applying the dominance property for the rows. So now you see this is the first row and this is the second row. So here the in the first, if you compare these two, so 1 is dominating 2, minus 2, but here minus 1 is not dominating 2. So we can't cancel this the second row. So then let us compare these two rows. So here 1 and 1 both are same, but here minus 1 is dominating minus 5 because minus 1 is bigger number than minus 5. And here the 5 both are same, but again minus 1 is dominating minus 5. So that means the strategy 1 is dominating the strategy 3. So the strategy 3 will be cancelled. Then again if you see these two strategies, and here 1 is dominating minus 10, but minus 1 is not dominating. And let us compare these two. So 2 is dominating minus 10 because minus 2 is a bigger number than minus 10, and these two are same, and again minus 2 is dominating minus 10. So that means the second strategy is dominating fourth strategy. So that means the fourth strategy can be eliminated. So now we will come to the columns. So now let us come to the first column. The 1 minus 1. 1 is dominating minus 1. Minus 2 is not dominating 2. So let us compare these two then. And here the 5 is dominating 1. And here minus 2. So both are same. So that means the third strategy is dominating first strategy. So then we can remove the third strategy. Then fourth strategy, and minus 1 and minus 1 both are same, but 10 is dominating 2. So then 10 is dominating 2. So that means we can able to eliminate this fourth strategy when compared with the second strategy. So we can eliminate. Then we left with only 2 by 2 matrix, which cannot be reduce the columns and rows by using a dominance property. So we can easily solve 2 by 2 matrix by using the mixed strategy problem by augment method. So let us solve this 2 by 2 matrix. So by applying the augment method, so here we need to first see the augments. We need to calculate the augments. So here if you see the augment is the difference between these two. So minus 2, it will become minus 4, but we will be taking augment value always positive, so it becomes a 4. And here the 1 minus of minus 1, it becomes a 2. So augment value becomes a 2. And here again in the columns, if you see the augments, and the difference between minus 2 minus 1 minus 1 minus 2, it becomes a minus 3. So minus will not be there for augment, so we will be taking 3. So 1 minus of minus 2, it becomes a 3. So this also will become a 3. So now if you calculate the probability of for first strategy of player A will be 4 by 4 plus 2. That means 4 by 6. That is nothing but the 2 by 3. And the probability P2 is equal to 2 by 2 plus 6. That is equal to 2 plus 4, 6. So then it will become 1 by 3. Similarly, if you calculate the probability is Q1, that is equal to 3 by 3 plus 3, that is 1 by 2, and Q2 will be 3 by 3 plus 3, that is equal to 1 by 2. So that finally the value of the game will be 1 into 2 by 3 minus 2 into 1 by 3. So the value of the game is 0. So finally we can say strategy of player A is in the probability of A of 2 by 3 comma 1 by 3 comma 0 because the third and fourth strategy we have not considered, and here because that is cancelled by dominance property. And a strategy of player B is in the probability of B of 1 by 2 comma 1 by 2 comma 0. So the value of the game is 0. So that is how we are going to solve the problems by using practical problems by using this game theory. We will go to the third problem. Player A and player B play a game where each rolls a 6-sided die numbered from 1 to 6. The rules are as follows. So here there are two players, player A and player B, both of them having one die. So this die having number from 1 to 6. So this die having this is like a cube. Cube have 6 different sides. So this die also will have 6 different sides. So each side one number is there. So 1 to 6. When they throw the die and player A and player B, they will take the addition of these numbers. If this addition of this number is even number, player A will get the money. And if the addition of the number is odd number, player B will get the money. So if the addition of the number is even number and player A will get on the player B die number equivalent value. For example, when he is throwing the die, so for example if he get 1 and player 2 got number 3, so 1 plus 3 is the even number,
So player A will get 3 rupees. So likewise they are going to get the money. So now we need to develop a payoff matrix from the respect to the player A and find the optimal strategy for both players. That is the problem here. So now first we need to develop a payoff matrix with respect to player A. So now let us say here this is the player A and here is the player B, and player A use, there are 6 strategies 1 to 6. Player B will use 6 strategies from 1 to 6. And here if you start from the first row, now player A is playing only the one side, the one numbered side of the die. At that time, if he also play one side number, then 1 plus 1 it becomes a 2, so he will gain 1 because the player B number is 1. And again if both of them are playing and player A get 1 and player B get 2, so then the addition becomes a odd number. So odd number means player A will lose the money, so that 1 rupee he will lose, so that is why it is minus 1, because we are making this payoff matrix with respect to player A. So then the likewise for 1 plus 3 it becomes a 4 even number, but number on the player B die will be 3, so he is getting 3. And 1 plus 4 it is 5, it is even number, he will lose 1 rupee minus 1. And 5 plus 1 6, so his number is 5, so he will get a 5 rupees. And in the similar manner the 6 plus 1 7, it is odd number, so he will lose 1 rupee minus 1. Likewise if you make the payoff matrix, so the payoff matrix will come like this. So let us see the last row. So here he is selecting 6th the die number, and 6 plus 1 it is 7, so he will lose minus 6 rupees, so minus 6. So 6 plus 2 it is 6 plus 2 is 8, so it is even number, so he will gain this 2 rupees. 6 plus 3 minus 6, so and again the 6 plus 4 10, it is even number, so he will get 4. And 6 plus 5 it is odd number, he will lose 6 rupees. And 6 plus 6 it is 12, so it is even number, so he will gain 6 rupees. So if you observe carefully, so here he is playing minus 2 rupees, so here it is odd number, so it is minus 2, here also odd number minus 2, here also odd number minus 2. And here it is a positive, and player B number is 2, and here the positive even number, so player the B value is 4, and here player B value is 6. Likewise we can able to complete the entire table. So then once after we get the payoff matrix, we need to we need to first apply the mini-max criteria. So if you apply the mini-max criteria, so here the minimum value in the first row is the minus 1, second row is minus 2, third row is minus 3, minus 4, minus 5 and minus 6. And in the same manner column wise if you see, the maximum value will be 1, 2, 3, 4, 5 and 6. So here if you take the max mini value, minus 1 is the max mini value, mini max value is 1. This 2 is not equal. So that means it is the mixed strategy problem. So we need to go to the dominance property. So if you go to the dominance property, so here applying the dominance property, so first row with the second row, so the first strategy is dominating second strategy, and here the second strategy is dominating first strategy. So there is a controversy for the first column and second column, so it cannot be cancelled. Then if you compare the first strategy with the third strategy, 1 is equal to 1, so it is neither A is 1 is dominating nor 3 is dominating. But here in the second column, minus 1 minus 3, so minus 1 is bigger number than minus 3, so the first strategy is dominating third strategy. So likewise here it is same, again here first strategy is dominating, and here both are same. Here the second strategy, the first strategy is dominating. So that means the total third strategy is dominated by first strategy. So we need to remove, or we need to eliminate the third strategy from the payoff matrix. Then again we will go to the first strategy comparing with the fourth strategy. So here the first strategy is dominating second strategy, but in the second column the first strategy is not dominating second the column. So fourth strategy in the second column. So either first or fourth is dominating each other. Then we'll go to the fifth strategy, and when you compare the fifth strategy, so here the one is same, and minus 1 is bigger number than minus 5, and 3 is same, minus 1 is bigger number than minus 1 is bigger number than minus 5, again 5 is same, minus 1 is bigger number than minus 5. So here the first strategy is dominating the fifth strategy, so we can comfortably eliminate the fifth the strategy. And if you then again if you compare the second strategy with the first strategy with the fourth strategy, it is not dominating. And again second strategy with the fourth strategy, so minus 2 is dominating minus 4, 2 is same, and minus 2 is dominating minus 4, minus 2 is dominating minus 4. So here all these places, so second strategy is dominating the fourth strategy, so the fourth strategy can be eliminated from the payoff matrix. Then again by comparing with the second strategy with the fifth or sixth strategy, and minus 2 is dominating minus 6, here the both are same, minus 2 is dominating minus 6. Likewise the second strategy is dominating the sixth strategy, so the sixth strategy can be eliminated. Now 4 rows we have eliminated by using this dominance property. Now you come to the column. So first column and with the second column, if you see the dominant, if you apply the dominance property, the minus 1 is dominating minus 1, 1 is dominating minus 1, and but minus 2 is not dominating 2. So again 1 is dominated by 3, that means the third strategy, and 2 is same. So here by comparing it with the columns, the third strategy is dominating first strategy. So in column elimination, whichever is dominating, so that column need to be removed. So here third column need to be removed. Again second strategy with the fourth strategy, the fourth strategy is dominating second strategy, and 2 is dominated by 4. So finally fourth strategy is dominating the second strategy. So we can remove the fourth strategy. And again fifth strategy is dominating the fifth strategy is dominating first strategy, so the fifth strategy also can be eliminated. So finally there are only 2 by 2 matrix is left, that is 1 minus 1 minus 2 2. So if you take this the 2 by 2 matrix, we can easily apply augment method, and we can solve the problem. So by applying the augment problem, so we need to first find the augment value to this matrix, 2 by 2 matrix. So augment value is difference between these two is the will come here as a augment value. So 2 minus 2 it becomes minus 4, but augment value will be always positive, so it will be 4. Then 1 minus of minus 1, it becomes a 2, so augment value will become 2. And again augment value in the column, here the augment value in the column will be difference between these two, that means minus 1 minus 2, it becomes minus 3. So but augment value need to be in positive number, so it will be 3. And again here for the second column, so again augment value will be 1 minus of minus 2, that is plus 3, so 3. Now let us find out the probability of the player A for the first strategy, that is P1 is equal to the 4 by 4 plus 2. So that means 4 by 6, and that is equal to 2 by 3. And again here the P2 is equal to 2 by 2 plus 4, that is equal to the 1 by 3. So these are the probability for the first and second strategy of player A. The similar manner, if you find out the probability of player B, that is Q1 and Q2, the Q1 is equal to 3 by 3 plus 3, that is equal to 3 by 6, that is equal to 1 by 2, and q2 will also be 1 by 2. So now if I wanted to find out the value of the game, v is equal to 1 into 2 by 3 minus 2 into 1 by 3. So that becomes a 2 by 3 minus 2 by 3, that becomes a 0. So finally we can conclude that the strategy of player A is in the probability of A of 2 by 3, comma 1 by 3, comma 0, comma 0. And the strategy of player B is in the probability of 1 by 2, comma 1 by 2, comma 0, comma 0. The value of the game is 0. So that is how we can able to solve the problems. So now let us go to the last problem, the fourth problem. So two educational technology firms, company A and company B, are competing to supply the smart classroom solution to a group of higher education institutions. And each company offers different value added services as a part of their professional to win the contract. The strategy of company A are providing AI based adaptive learning software, and B will be offering the smart boards and interactive classroom kits. And the strategy of player B are free teacher training workshop, customized content packages aligned with the university curriculum, and 24 by 7 technical support and maintenance. And the D is integration of mobile app for remote access and progress tracking, considering the payoff matrix. So consider the payoff matrix with respect to of player A and player B and solve it optimally. So here he also given the relation between company A and company B with the payoff matrix, and he also given the what is the first strategy for player A, that is nothing but the providing AI based adaptive learning software, and second strategy for player A is offering smart boards and interactive classroom kits. And here for player B there are four different the strategies. The first one is free teachers training workshop, and the second one is customized content packages aligned with the university curriculum, and 24 by 7 technical support and maintenance, and integration of mobile app for remote access and progress tracking. So these are the strategies. Now we need to find out, we need to solve this problem. And what is the first method what we are going to follow? We are going to apply the minimax criteria, because here already they given the payoff matrix. We directly apply the minimax criteria, and here in the first row the minimum value is -1, so the minimum value here is -1, and here the minimum value is 2. So 2, and again column wise if you see, here the minimum value is, the maximum value is 4, and here 3, and 3 and 6. So minimax value is 2, but here max mini value is and 3. So both are not equal. So it is a mixed strategy, the problem. So mixed strategy problem we need to solve by applying the dominance property. So if you apply the dominance property, so to this the 2 by 4 matrix. So now let us first apply the dominance property to eliminate the rows. But here if you compare the first strategy with the second strategy is dominating first strategy. But here also second strategy is dominating first strategy. But when it comes to third column, so the second strategy is not dominating first strategy. So that means either first or second is not dominating each other. Then let us come to the column. So because there are only two rows, so let us come to the column. So if you come to the column, here the both are same, and here the first strategy is dominating second strategy, because the fourth is the bigger number than 3. So here the first column is dominating the second column. That means whichever is dominating, that we need to remove. So here we will be removing the first strategy. Then again if you compare the second strategy with the third strategy, and the second strategy is dominating 3, but the second strategy first strategy, sorry, second strategy of player B is dominating the not dominating the third strategy. So here we can't compare. Then again if you see 3 is dominating -1, but 2 is not dominating 6. So that means this 3 by 2 by 3 matrix, we can't further reduce it. So if you can't further reduce it, so the another solution for solving the problem is graphical method. So here we now we need to find the expected payoff function of player A, and here there are only three strategies: strategy 2, 3 and 4 from player B, and strategy 1 and 2 from player A is left. So now we need to find the expected payoff function. So let us make a table. B alternatives left are second, third, and fourth, and then expected payoff function will be now for first alternative. Let us say if player A plays the first strategy, let us say the probability of gaining will be 2 into x. And if suppose if a player A plays the second strategy, when the player B is the playing the first strategy, then the probability of second strategy will be 1 minus x, because the x is the probability of getting the first strategy, and probability of getting the second strategy will be 1 minus x. So the expected payoff function will be 2 into x plus 3 into 1 minus x, that is equal to minus x plus 3. So here 2x plus 3 minus 3x, so minus x plus 3, and the expected gain of a will be at x is equal to 0, so this value will become, the function value will become 3, and if x is equal to 1, so the function value will become 2. So in the same manner, if you write the expected payoff function for the third strategy, that will be 3 into x plus 2 into 1 minus x is equal to, so 3x minus 2x, it becomes x plus 2. So here at x is equal to 0, this become, the function value become 2, and x is equal to 1, the function value become 3. And for the fourth strategy, the expected payoff function will be minus 1 into x plus 6 into 1 minus x, that is equal to minus 7x plus 6. So that will be now at x is equal to 0, this function value will become 6, and at x is equal to 1, the function value become the minus 1. So this is how we will be getting the A's expected gain. Now let us see and plot the gain function of player A with respect to different alternatives of B. So these are the B alternatives, and these are the A's expected gain. So we will plot the graph. So if you plot the graph here, so these are the B alternatives, and this is the A expected gain, which we have already discussed. Now if you take the graph here like this, so these are the 0 to 10, and here this will be from the 0 to 10, and it will be minus side. So this came early. So now let us draw the first B alternatives, that is 3 to 1. So 3 to 1, that means at x is equal to 0, 3, and at x is equal to the 1, it will be 2. So we will draw one graph like this. So this will be like this is like a B alternative, and this will be the B third alternative, B's third alternative, that is 2 to 3, and the fourth alternative will be 6 to 1. So now if you observe, all these three the functions are meeting at one place. So in this case we can take any two alternatives, because the value will be the same. So let me consider the first two alternatives. If I consider these two alternatives, then let me find I will find the I will find the strategies of player A and player B for remaining payoff matrix. So here I will be first considering the two alternatives. Now if I take, so now I need to calculate the augment value for this 2 by 2 matrix in order to solve it. So now I will be first getting the augment value. So augment value for the first the P1 will be, augment value will be So difference between these two, that means 3 minus 1, it will be 1, and difference between these two will become the another odd value here. So that is a 2 minus 1, it will be minus 1, and odd value should be in the positive, so it will be taking as 1. So now let us consider the odd value for column. So odd value for column will be again the difference between these two, second column. So 3 minus 1, 2, it will be 1, and second column will be the 2 minus 3, it will be again 1. So now if you see the first strategy of player A, probability, the P1 will be the 1 by 1 plus 2, that will be 1 by 2, and P2 will be 1 by 1 plus 2, that is also 1 by 2. The surprisingly, the same Q1 value also 1 by 2, and Q2 value also 1 by 2. So now the value of the game will be 2 into 1 by 2 plus 3 into 1 by 2, that will be 5 by 2. So that is how we will get the value of the game. So finally, the strategy of player A is in the probability of A of 1 by 2 comma 1 by 2, and the strategy of player B in the probability of, because the first and second strategies are not counted here, so I will be taking as 0, 0, 1 by 2, 1 by 2. So that is how I will be getting the probabilities, and the value of the game will be 5 by 2. Thank you.